We're here at IntelliSys 2025, and I'm here with Michael Müller. Michael, welcome.
Welcome. Hi, nice to meet you.
Yeah. Can you tell us a bit about yourself, about your academic journey so far?
Definitely. So my academic journey started years ago as a bachelor student in mechanical engineering.
Okay.
After 6 years of working experience, I decided to go for electronic systems engineering and management.
Mm-hmm.
So first time when I get into contact with artificial intelligence. And also the master thesis project was like teaching a pressure cooker to smell what's inside.
Okay.
And this really drove me curious about the topic, and also the reason why I'm here right now and doing my PhD in parallel.
So I have to ask, did that work? Did you teach a pressure cooker to smell what's inside?
The question is if you want to have the technical, honest answer.
Yes, please.
Oh, yeah. So I did an investigation on 5 different types of food.
Yeah.
Food where I am capable to smell the difference. So I'm not a trained smeller or a taster, yeah. But the sensor was able to find different patterns, to measure different patterns.
Okay.
And machine learning algorithms showed it, but it was quite a short study, yeah.
Okay, we're going to skip over that and more present. What are you currently doing?
At the moment, I'm working on optimization of food and beverage preparation with machine learning concepts.
Yeah.
Detailed view on coffee machines, because coffee is quite a simple drink. You just have coffee and you have water, some temperature, some pressure, but that's it. Yeah? And so you do not have many ingredients as you have in food, for example, and you just prepare the coffee for one person. So it's easier, not that complex as you have for a soup or a cake, for example. Yeah. And there really the target for me is to see how many coffee powder it needs to fulfill your need of coffee, that you say, okay, the coffee tastes, but also to reduce it to the amount that's fine in terms of sustainability, because the less coffee you use, the more sustainable the drink would be. Okay,
and that's what your current paper is about?
Correct. The current paper is like about a data acquisition system to really collecting real-world data, because like for other projects you can also simulate data, do it in a synthetic way, but here it's not possible because I cannot assume how you drink your coffee, for example. So I really have to offer you a coffee in experiment and ask you before about your context. So are you awake that day? What's your mood? Do you feel warm or cold? It's not just nice questions because I like it. It's more like questions to really have your context, because everything of these questions have an influence on your taste perception.
Wow.
The perception itself, it's not literally really validated for coffee, but for food.
Okay,
and therefore, and now I really try to get the patterns of coffee. Okay. And also, so really easy example is like 40 degree outside, maybe you do not smell anything. Why give you a coffee with 10 grams of coffee powder when I also can give you 5 grams of coffee powder, already saved 5 grams.
Result. Okay.
Definitely.
Are there any conclusions in your research?
So far, yeah. So gathering real world data is really hard because also to have a high quality of data, because the challenge is to get the data from the humans, your testimonials in the experiment, but you shouldn't import any bias. Means you shouldn't interrupt the people in their habits during the day. So it was like 2 experiments, 2 locations, 2 workplace environments. So people are running from one meeting to the other. You cannot come up with a questionnaire like asking 1,000 questions and measure the
they'll be annoyed with just being interrupted.
Definitely. And therefore the challenge is really to gather all this information, but in a way to do not disrupt them, to really have a high quality data set. But the biggest challenge is to get a lot of data. Yes. Definitely, but after 9 months now of experiment, it's like about 3,000 rows of data that we have from 89 participants. It's not big data set for machine learning, definitely I know, but
it's a start.
Definitely, and this is what it's all about, yeah.
Okay, excellent. So is there something that came up during your research that people might not know about, or is a little known fact?
Yeah, definitely.
Anything interesting to share.
Definitely, also something.
It's coffee. Everybody likes coffee.
Yeah, right? I know, and everybody can talk with me about the topic. So so after 1 year of research, I really had a point that turned everything vice versa, because first the idea was to always prepare the best coffee. But best coffee you cannot do with the recipe. Best coffee would be on vacation with your family, enough time for you.
So you enjoy it more.
Definitely.
Psychologically.
Definitely. I can just change the recipe, not the condition. Yeah. So you are where you're right now. So But what I realized then is like for 1 cup of coffee, there are 140 liters water consumed in the whole process chain. And I mean, we're talking about this amount of coffee in a bathtub of water. I don't want to say wasted, but used for it.
Yeah, sure.
Definitely. And therefore, it's like 8 grams of coffee powder for this cup. Means if I'm just able to reduce it by 1%, what's already in the tolerance of the throwing of the machine, I can do a big story with it because of scalability.
Okay, so if 8 grams becomes 7 grams, it saves half a bathtub of water.
Definitely.
Or something, yeah.
Definitely. And if you take into consideration that there are 2 billion cups of coffee drank worldwide a day, it's quite a nice story. Okay. And this brought me to the point, it's not about having a 4-star perfect coffee, it's about having a 2-star coffee that's okay, or a 3-star coffee that you already like, but with an optimized, let's say like this, amount of coffee powder in terms of sustainability. And then nobody before matched it really with an algorithm to bring sustainability and taste. And maybe if you come back to food preparation systems, also health into one optimization goal.
Okay, sounds awesome. About the conference, how do you find the conference so far?
Really nice. I was already here last year.
Yeah.
And I really enjoyed it and also decided to come back. Why? Because there are people from all over the globe, what I really like for networking. And you get so many different perspectives. It's not about one algorithm to understand it. For me, it's getting the big picture worldwide. Also, what drives the people. And this is really interesting. And all people that I meet here are really curious and motivated, what really makes fun.
Oh, that's great.